Also, actually, I'm basically replying to chat if you guys want to use the team account login. Okay, so hello, my name is Harris, and as again today with Aiden and Tyler, we came again 2 weeks ago to the show, and then we were teaching about the Lego Digital CAD. Today we're going to be teaching more about the Virtual Robotics Toolkit, as you can see on screen. Okay, so we're just going to move on to the next slide. Okay, so this is Virtual Robotics Toolkit. We're from the Second Rebellion Robotics. We're an FTC team located in Walnut, California. And then in this lesson, we're mostly going to be showing about how to use the Virtual Robotics Toolkit, which is what we tried a little bit, last 2 weeks. But then we're going to go more in depth with the software, such as talking about like different special features and an advanced mode inside. We're also going to be showing like different sample robots inside the Virtual Robotics Toolkit you can use. And then we're also going to compare the Virtual Robotics Toolkit software to the FLO physical version that we actually acquired. Okay. So this will be our table of contents for today. We're going to start off with an introduction, and we're going to go through the opening software, and then we're going to talk about the simple mode, and then advanced mode, and then we're going to show some maps that we can actually use inside the Virtual Robotics Toolkit, a feature layout, and then we're going to show how you can change the orientations when you're moving inside the Virtual Robotics Toolkit. Virtual Robotics Toolkit actually very similar to CAD software such as Fusion or Onshape or Inventor or SolidWorks, as in you have to like right click, you're moving inside a virtual 3D space. And then we also have to talk about connecting with Mindstorms. And then we're going to talk about how you can connect the Virtual Robotics Toolkit to the Mindstorms one inside the Virtual Robotics. Okay. And then we're going to be talking about how you can import a robot from another software, such as LDC. We're going to talk about how sensors work inside the Virtual Robotics Toolkit, since it's a virtual space, so all sensors may not exactly work as well. And then we're also going to be talking about, let's see, EV3 Mindstorms. We're going to talk about how you can program, just an review of programming, an example robot using the VRT software, and we're going to perform some simple color sensor tasks, some common issues that may occur inside the software, and then VRT versus the physical robot. Okay. Introduction. So this is just another flowchart of how each software is connected to another. We're talking about Virtual Robotics this week, Virtual Robotics Toolkit. Okay, so then we're going to talk about the EV3 Mindstorms, which is on the left. This is basically the programming software that we're going to use. We're also going to be talking about LDC and LDRAW, right? Last week we talked more about LDC and LDRAW. It just exports an LDD file, or kind of such as a CAD file that we would use inside the program. In this week, Virtual Robotics Toolkit will combine both the EV3 Mindstorms and the LDC. Okay. So I'm going to go to the next slide. So this is the view once you open the software. Basically, it'll show this loading screen right now. This is just, sometimes you might not realize it, but the software already finished loading, and you have to move your cursor up to the very top for the software to actually register. And then you can actually click a new file, because it sometimes looks like it's still loading, but it isn't. Okay, this is just a notice because it happens a lot and you don't realize it sometimes. So let's see, once we download the Virtual Robotics Toolkit, we're gonna show this little video right now. We can just move our cursor to the very top and then add new file, and then we can go into we can scroll down and see which one we have. We're going into the sandbox EV3 right now, and once we load the environment, we can go back to the top. This is where all our menu controls are when we're inside the simple mode, which is what we are in right now. Once we open the software, it just automatically goes to simple mode. Okay, so this is just a description of what each button does inside the simple mode. So we have our simulation project video, or our first steps to open a new project inside the simple mode. We also can start the simulation. We can stop the simulation. We can manage robot attachments. We can view the scoreboard. The scoreboard is something like what we can play with some different maps such as Sumo inside the virtual robotics toolkit. We can also manage the robot attachments. Managing robots attachments is basically you can add different color sensors. You can add buttons such as a touch sensor, or you can use a lifter mechanism inside the software. Okay. We can also open or close the EV3 virtual brick. We can do full screen EV3 program, which would full screen the Mindstorms program if we have that open. We'll cover that a little later. We can also full screen the learning environment. We can full screen VRT, and we can split the interface to 3 different sections. If we want to, let's say, simultaneously program, learn, or work on the VRT. And then we can split it into 2 interfaces. And then on the very right, we can also just close the program. So this is just a small description of how to control your camera inside the Virtual Robotics Toolkit. Every time you open the Virtual Robotics Toolkit software, this will always be on the top right of the screen. So you can see that our first option, which is to look, is just to turn around and have your camera position in the same place, but you move your angles. And then that is with the right click. You can also do truck, which is you physically moving around. And then that's going to be left control and right click. You can also do an orbit, which is left alt and right click. And that's not changing where you're looking at, but changing where you are. And then lastly, zoom, which is basically using the scroll wheel to zoom. And then Tyler.
Okay, so now we'll be talking about how you get into advanced mode, which is how you start exporting or importing your robot, and then you have more freedom and more control over it. So once you're in your program, you're going to press F12, and this is going to bring you into advanced mode. It'll bring up this prompt, and then you'll see on the top, you have a lot more options that way and what you can do. So you have the same buttons as you would normally have, but you have more of them. So you have more freedom and more options, I guess. Starting from the left side, we have the add new file and the open file. These are the same as before, and we could also save the current project you're working on. You have undo and redo if you've messed up. It's pretty standard. You have start, play, and stop, and these are the same as they were. And then you have previous save state. So if you really messed up and no amount of undoing could do it, you could go to a previous save state. And then if you go too far, you could go to the next save state. Then you have movement options. So you have truck camera, which is you're able to move around freely. And then you have object selected. So you could select object. You have find object if you can't find your robot, if you've thrown it off the map somewhere. You have rotate select object, which is rotating the object. And you have import robot settings for the robot, so changing the attachments. Real-time data, scorekeeping. These are more for if you're doing the interactive maps or with another person. And then you have object library, EV3 brick, and mission main. So these are more for if, well, the EV3 brick is pretty explanatory. The mission man thing is being added upon, and then edit code is where you edit your code. So with the advanced camera angles now, we have these drop-down menus underneath. So you have the near far clip options. And what these are going to be doing is they're basically how far the world will load in. So the closer you are, the less it would load in. So if you have a weaker computer or something, you could load less in and it'll be easier. So the default is set to 1,000, which is really far. So what we found is that 100, somewhere around there, is pretty good for both performance, and then you can see everything at the same time. And then you have camera presets, which is different camera presets. That one is currently a lot like a lot of computer-aided design softwares, such as Onshape or SolidWorks or Fusion. So if you're used to those, this camera will be easy. You have perspective mode, which is uh it's a view where all X, Y, and Z will be the same. So no matter how far you zoom out or how far you zoom in, the perspective of the robot will not change at all. And then you have settings, which we'll go into later, or tracking settings. So here. So in order to see these, you're going to have to, or you can see we're using the default ones right now. So the right click, and then we're just looking around. And then in order to see the drop down, or this is what truck looks like. So right click in truck. This is orbit and left alt. So, and then we could zoom with the mouse wheel. So in order to see these drop downs, we're gonna have to move the brain because it's in the way at the moment. So you can see there's these 4 buttons at the top. So this is what the actual what the clipping looks like. So you can see we've just made it so the world renders that's really close. So we found that the default being 1,000 is a bit much. So you could always limit it. You could find whatever works for you. That's what's nice about the options. So you can see we have the whole world generated, but if we start limiting it, it'll start disappearing slowly. And there's a lot of options that you can do, a lot of settings. Again, this is for like if you have computer issues, like you have a weaker laptop or something that won't be able to generate the whole world. This is where you would make it so it's easier for you to start doing it so that everyone can play with it and it's not limited to only people with powerful PCs. Okay, and then the grid is just to see how many chunks or how many squares are being loaded in at a time. You can see the whole map is that many, and then you can see how many times or how many are being loaded at the same time. Okay, so now that we're back at our little robot playground, we're gonna exit, and then we're gonna go to the previous settings. So these are the ones I was talking about that are very similar to Onshape and or any other CAD software. So it's just like the normal view, except we don't have that square with or the cube with you that you can move around, which is a bit weird, but it's not the biggest deal. So there's a lot of freedom and a lot of options that you can do for your camera view, and some of them are more helpful than others, and then some are slightly useless, but everything has that. So now we're going to go to the perspective mode, which means no matter how far you zoom out or zoom in, the perspective is always going to be the same, as you can see with you. So as we zoom out, the perspective of where we are or where the camera is doesn't change. So you can always see what you're doing. And then if you stop, you can see how it's different. Okay. So with our last option, which is the tracking view, what it'll allow you to do is select an object. Or just quit out of the brain real quick. What it allows us to do is it allows us to select an object that we would like to begin to track. So we have to select the object and then we press follow whenever the video catches up. Okay, so we select the robot. You have to right click the robot and then you press follow. And then, so what this would allow us to do is when you're moving, it will no matter where the robot goes, the camera will start following the robot. So as we press play, you can see the camera follows the robot. Now, this is one of the camera views I think would be more useful than some of the others because if you're, trying to do, say, the 2019 city shaper map, and you really want to see where you're going, this is where this camera angle would be very useful. Um, so no matter which way you're going, it'll always track. And then we have this view, which is a look at. So this is the truck one, which means that no matter it'll have the same angle. If you turn or anything, it'll still be at the same angle. This could also be very useful in those maps when you're trying to get a good look. And then the next one is going to be look at. So the look at one is more like a camera panning. So say your camera's there's a camera on a tripod and it's looking at the robot. It's more like a slow pan like that. This could also be very useful in the same way when you're trying to really see where you're going or what you're doing. That's just we see as we complete the little block mission here. You could always revert to different cameras also. So if you don't like one, you could always just change it up. Next, we're going to go to the map showcase. That's a pretty large amount of maps that you can pick. So if we go to the video, you can see these are if you move the brain, you can see the maps that are available. And then you can see that there's the sim basic maps, which are these ones. Okay, so you can see how there's the sim basic maps, which are these ones once you move the brain. You can see competition, first Lego League, and WRO. So these are maps that are just fun to play around with. Though some of them are two-player, where you could either play on the same laptop, and then every single one has a description to what they do on the bottom, which will bring you to a web page. So this will describe everything that the map has to do, and then everything that just all the information you could have. So that's in basic. And then if you go to competition, there's nothing there at the moment. Something's going to be currently added. I don't have a time frame on that, but and then we have first Lego League, which is what you guys do. So as you can see, we have all 2019 maps, or not 2019 maps, all maps from past 4 years, and you can see what they do. And then you have WRO, which has 4 maps or 3 maps every year. So there are a pretty good amount of those for you guys to mess around with or play with. So there's a pretty wide variety of maps that you can choose. And then you could make fun on all of them. Okay, so once we found or click on any specific map, this one's going to be this one right here is going to be the 2019 City Shaper map. As you can see, it's exactly the same as it would be in a normal FLL field, except you don't have the table. So all the objects are the same, all the missions are the same. So guys some of you should at least be pretty familiar with it. As you can see, you can move the robot just like normal, and then you can try and complete a mission either handheld or by making a program, which we'll show you how to use later. As you see, you could just run into any objects. Everything has physics right now. You could turn those off, but I wouldn't recommend it. And then if we go into the robot settings menu, you can see how we can add either a color sensor, a touch sensor, the lifter, which is what we're going to add at the moment. So as we add the lifter, currently right now the lifter's stuck in the ground. So if that happens, usually you just want to pick up the robot, but for some reason it wouldn't let me here. So that might be a problem you come up with, but that means you just have to reload the software. It's not that big of a deal. So you can see as we just limp over here, we're going to take it off, which is the same process. So if we go into the robot settings and then you just click it again, you can press remove. So it's pretty easy, and then if you just don't want to code in something or actually build it in LDC, it's easy. Also, one thing to note is that the maps are suspended in midair. They're all floating. So if you somehow go off the map, you will fall forever, basically. So try not to do that. If you do, just reset. It's not too big of a deal. It's kind of funny to watch as well. So you can see we go through these options. We have a lot of them now because of the advanced mode. We're going to go into environment in just a second. So in the environment, we could change things like the gravity, the physics of all the objects, and then just so we could make it more complex or more fun for us. So you could put on moon gravity or something. But what we're going to do at the moment is we're going to change the color. So this will give the map a hue. And then I think it's going to be purple. And then we could have a background. As you can see, the list is pretty extensive, so you could have a lot of backgrounds. And then as you can see now, our Lego map now has forests in the background, and it's purple. So more options to mess around with or do something that you like. Make it pretty to look at because you might be staring at it for a while. As you can see, this is what the rotate view looks like. So if you have that on, it'll look like the circles. And then this is what the pickup looks like, where you could drive X, Y, and Z. It's more of arrows. So this is just settings for the brain. So if you want to change something, it's pretty easy to do so. And then I cannot read that. That's fine. So that's locking onto the robot, which is just or finding objects. So that's if you lose, like if you spawn in a single Lego for some reason and you really want to see where it is, that's what you would use. Okay, so now we have changing orientation. So now that we're back in the sandbox mode, um, now that we're back in the sandbox mode, we can see our robot here. And we're gonna press find or the object and then lift up the X, Y, and Z. So as you can see, we can move it any which way we want. And if we want to throw it to the ground, we can. If we want to just change the orientation, it's fine. So now we're going to do a rotate. And you can see the map really doesn't matter here. No matter what you do, it's just going to rotate. So again, if you want to get into like a tight spot or you just really don't want to drive somewhere, this is pretty useful. And if your robot's floating a bit, doesn't matter because currently we do have gravity on. So if it's floating like it is now, it's just press play and then it'll fall back to the ground shown here. And then if you do stop, it'll be back where it was. So infinite options you could do with this. It's pretty useful. Also, the map you can also move around. So this is less useful, but I guess it's fun at the same time just to mess with because you could move the whole map and then the bricks stay and your robot stays. So I guess this allows you also to see what is truly the map. So you can see how all the playground stuff around you moves, but your robot doesn't. So now we're going to go over connecting to Mindstorms. Connecting to Mindstorms is pretty simple. So we have that dual screen button. That's what you're going to press, and then it'll bring you into dual screen mode. So once you start up any program, it connects seamlessly to the VRT through Mindstorms. So once you're in Mindstorms, you could open a project or start a new project. It doesn't matter. And it's just going to be like using any other brain. So as we open this up, we'll drag a few blocks in just for an example, and then we'll play them. So it's exactly how you would usually do if you're going through Wi-Fi or Bluetooth. So you just press the Wi-Fi option, you press download, and then you just have to scroll through normally, like you would normally do, and you can see it's running the program. And now I bring it over to Aiden.
So I'm sure most of you guys already know how to use the EV3 Mindstorm software, but we're just gonna go over it anyways. So this is just basic movement blocks. So if you could play it. So basically for movement blocks, you can see I have all of my pieces down here and there's the dividers above it. So I'm gonna pull out a medium motor here, but it automatically goes to A port. So, but as you can see on our robot, we actually don't have a medium motor. And if you want to see that, you can go to this tab here. And then in order to go there, you can just use the pad at the bottom and click on port view. And then here we have all of our sensors. And you can see that the sensors are plugged into all the ports, but here we only have motors plugged into ports B and C. So if you build your custom robot and import it, then you'll be able to use the medium motors or any other motor that you would want. But on the default one, there's only B and C. So after we've dragged out our movement block for both motors, it automatically goes to B and C because our robot is connected to it. And then here we have the amount of rotations and the speed. So if we just run it right now, then it would just go forward one rotation. It's pretty simple. Okay, and this is about loops. So let's say we have our one rotation here, and then we want to make it go forward a certain amount of times. You would change it to count, and then 2 times. And then, as you can see, it would go forward 2 rotations instead of 1. Okay, next is sensors, which is a little bit harder to use. So you can play the video. So as you can see, we're back on our just one motor block. So I'm gonna actually pull out a loop and set it to color sensor and color, and then set it to black. So that first block, basically what it does is it just turns the robot left. And then what we're gonna do here is make it go forward a tiny bit. And every time it goes forward, after it goes forward that half rotation, it's gonna check if there's a black color. So as you can see, it stopped when it hit the black. Okay, and these are custom blocks. These are actually really useful, and if you don't want to like keep doing the same thing over again. So what we have here, you just select what you want, go to tools, click custom blocks, and you can choose whichever icon that you want here, and then click OK. And then as you can see, it's just basically condensed into a tiny block, and then you can easily just, and it does the exact same thing as you can see here.
Okay, so yeah, I'm gonna be just covering a little bit of how I think we're gonna connect to the Mindstorms, and this is just some sample code that we run inside, and then we also programmed it with the color sensors. So remember, if you want to attach a sort of attachment, I'm just gonna pause the video right here. You can see that right now we actually have our 2 different views. We have the virtual robotics toolkit on the top, and then the EV3 Mindstorm software on the bottom. So what we need to do right now is, you can see on the top, we actually have 2 different color sensors on top of the robot. That's because we use the add attachment tool. And then in the bottom, we just have program that we already wrote. And now just play the video. Okay. So there's going to be another screenshot of the code a little later, but you can see that there's just a bunch of if statements and a bunch of loops inside the program. This is just to make sure that our goal inside the this loop is to have both of the color sensors align with one of the block lines so that it's straight. So we're just going to run the program a little. And then you can see in the bottom right, it's all the sensor inputs. So you can see how the sensors are actually changing. This is just how Virtual Robotics Toolkit runs its sensors. It's all condensed in the bottom right. Okay. in this example right here, this is just the code that we had inside the robot. So you can see that we have a very outside loop statement, which Aiden covered. And right now it's just set to 1,000 times because we just assume that it will be broken inside the code. Okay, so then the next thing, we have this color sensor. We're detecting if three on the robot right now is actually the right color sensor. We're detecting if the right color sensor is the color black. If it is, then we go into the top one and then we check again. Is the left one the color black? Because if both of the things are color black and both of the color sensors, then we know that we're on either a line or we have two different separate points that are black. And then if that's the case, we can just use a break statement, which actually Aiden didn't cover that much. But in the break statement, we can just exit out of all of the loops. And then in this case, there's nothing else to jump past to. So it just exits. And then if it isn't, then we just start rotating our robot around. You can see how we set the power levels to 25 and negative 25. So start turning in itself. We can also, if the color isn't black, and then we will check if the other color sensor is. If it is, then we can start turning the other way. But if it isn't, we're just going to keep driving forward until we sense the color black. This, if you are pretty skilled at programming, or if you get comfortable with the software, this shouldn't take that much long of a time. But if this was in the physical world, then we would actually have to do iterations because different, let's say, track lengths or your wheel might have different grips because depending on certain conditions. But if you're inside the virtual robotics toolkit software, every time you repeat the software, it's just going to be the same result. Okay. So this is the second example. And then in this example, I just want to note how right now, all the sensor lengths are changing. Usually you can also see the encoder counts that all of these motors have, the large motors. These motors all have encoders so that you can tell what position they are. And then these are pretty useful also when you're programming. Let's see what else. So, and then someone mentioned in chat that how do you move? You can see in the top right, you can just do the camera controls. These are always going to be in here when you open the software, just in case you kind of forgot or something. So you can always just look back to the top right if you have any issues with that. And then you can also see in the top bar, that's where we covered the software. That's there again. Okay. And then we can also see in the top left, there's the camera options, the 4 different camera options. And I'm just going to play the video. And then you can see how right now I'm continuously repeating the software. This is so that this is just testing to show how consistent the results are inside Virtual Robotics Toolkit. They might not be this in real life, but you can test to make sure. And then I just want to pause right here. This menu right here is what we open, and it's from the real-time data, which is right here. This has all of our sensor information. You can see that we actually have the RGB levels. In Mindstorms software, it doesn't specify. There's only options 1, 2, 3, 4, 5, 6. Right? But inside Virtual Robotics Toolkit, it goes super in-depth. There's also color intensity values. Inside the color sensor, it can measure it, so you can also test that. And then you can also, so in here, there's just a lot of what line sensor. It's basically a color sensor. A color sensor detects what color it is on right now, what it's pointing at. You can see that we have 2 color sensors on this specific robot, right? And then you can, right now, if you want to do, let's say, a line following robot, what we can do is just place 2 color sensors super close to each other. Let's say if you're following a black line, if you're following a black line, and then you can just make sure that it doesn't drift. If it does, then you can just turn the other way. And then, yeah, that's pretty simple. Although it does take a little while to actually build the robot inside the Lego Digital CAD software. Okay. And then you can see once we click the start button, we can move the robot back to the line. Right. So right now, we're just using the WASD keys. You can see that we can actually tell what keys we are pressing from this little small menu right here in the bottom left. This is, let's say, if you want to press the W, A, or S, or D keys, and then it would actually show up in the software. There's some other things, such as, let's see, sumo maps or other different maps that are such as soccer that have different controls that you might need like a medium motor to be controlled, or a small motor, or sometimes a sensor or something. You can use the WASD keys, and it might be like X or C or something. It just depends. Okay, that's the video. And then right now we're just gonna address the kind of common issue that may occur inside the software. So you can see right now we actually have, it says right now, Virtual Robotics Toolkit City Shaper 2019 not responding. This is because sometimes, as this is still a CAD, basically a CAD software, um, sometimes your computer might not be able to handle it, as in the example right here. One thing you can do is just wait. If you just wait, then it should be fine. But let's say if it just continues happening for like 10 minutes or so, then you might want to go into the task manager and then close the application and restart. With that in mind, you might have some data loss issues because the app just you forcibly closed the app. But it's just that sometimes Virtual Robotics Toolkit might not load, depending on computer. Okay. So we're going to do some comparisons. So this is the city shaper map, as we mentioned, right? And then we're going to also have this bottom sample code. You can see how it's just a simple loop statement by, I believe, 2 times to move both motors, to move one motor and the other motor. And then what we're going to do is we're going to run it inside Virtual Robotics Toolkit. And we had someone else on our team actually get a physical robot. And then once they got the physical robot, they ran the same code. And you can see how accurate the results are from Virtual Robotics Toolkit to real life. Okay. And then right now we're actually, we actually can just start the program. Just remember, if you want to go into advanced mode, you can just press the F12 key. And then this is just to remember, and this is very important to note because it is very hard to know which key to press if you don't have someone telling you or if you just don't look at the instructions. And it's pretty hard, but the advanced mode has a lot of useful features, so you want to be sure to know that. Okay. Or, yeah, so you can see the example, we have the bottom Mindstorms. And then inside the brick is pretty similar to what's in the real FLL world. And then we can just press the, so in the middle key, that's where you actually have to click something. That's where we're gonna, let's say, open a file or like change a setting. The bottom right, and then the left and top, those 4 key buttons, they're all used for, let's say, navigating inside the Mindstorms. Let's say you want to go into a specific folder, or if you want to move around inside the Mindstorms, that's where you would be. And then I'm just going to mention this, but in the top left, that's where if you want to cancel a certain task or something. And then, so you can cancel a certain task, or you can shut off the program with the top left of the Mindstorms key, which is right here. Okay. So you can see how the robot is moving right here. This is what happens in the virtual world. If I exit out of this, like this, we can see the physical comparison. This is just a sample FLL robot that we built. And then you can see how we can just run the program. You have to go under project inside the second menu to run the program. And then you can just click on the folder and then open a drop-down menu. And then in there, we can click program. And then you can see how similar the results are. I think in this case, the motors are actually a little bit slower, but that's just because friction. We know that all objects that have contact have friction. So I don't believe Virtual Robotics Toolkit is that good at calculating the friction. So it might just be a little bit slower in real life. So this is our second example. We have a different map inside the Virtual Robotics Toolkit. Sorry. Okay. So we have a different map inside the Virtual Robotics Toolkit. And then let's see. We can see that it's just this run right here. It's just a lot more simple sample code. We just have the robot going to drive straight. And then we have to remember to click the start simulation button on the top top of the screen. This is just to make sure that we don't accidentally, let's say, forget. And then in that situation, we can actually run the programs. And yeah. Okay. And then we're going to show the one inside in real life. I don't know. Okay. So we can see right here, we just have to navigate into the menu, and then the robot just drives forward. Okay. Okay. Does anyone have any questions? Let's see. So right now, I guess Aiden or Tyler, do you guys have anything to note?
Yeah, about the friction, you can specify in the environment if you want to have more friction or less friction. It's just slightly complicated and isn't very easy to do. So what I'd suggest is if after this and you're able to get to a physical robot again, you can use VRT and LDC as like a CAD software to just simulate what it's going to be, but I wouldn't base your actual
Yeah,
robot
so
off of this.
actually based on that, we can replay the let's see, I believe it's what Aiden, which one was it? I mean Tyler, which one was it about? This one? I don't remember. But basically right now I'm gonna try finding where we show where you can actually change the settings. It's under environment settings, right?
It should be the feature layout one.
Layout? Okay. So right now if we navigate to around towards the end, this is just to answer. Yeah, this is just to test. So right here you can see how there's actually Tyler, you can cover this.
Okay, so you see how there's the environment settings. So there's a lot of settings here. Not only can you change the maps, but you can change the amount of gravity there is, the amount of friction there is, and then you could do this just to have fun, or if you really want to make it as close to Earth as possible, you can do so. So as you can see, you have all these options and what you're able to do.
Yeah, and then you can see that we can also change how much gravity. So right now, if you memorize it, gravity is around 9.81 meters per second squared, right? I believe, yeah. And then, so this is actually simulated inside the program. You can see the y-axis, which is up or down, right? It's 9.81. Okay. And then we can also just change velocity, sleep velocity, and then yeah. You can also just restore the defaults if you, let's say, mess up on anything. Yeah. Okay. Okay. Any more questions? I guess I can show a little bit more of the maps in the map showcase. So I mentioned briefly about how there was we talked about like there was sumo, or there was also like what is it? Soccer. So if we just go into, I believe it's in under Sim Basics right now, you can see that we have sumo right here. If we just click the read more, we can actually describe a little bit about the sumo map. So give me a second. I'm actually gonna see if I can find it. Okay. And then we can also see that there's mazes and different stuff like that. I don't believe you can program EV3 with Scratch. I'm not that sure about that, but I don't think that's the thing. Okay, and then yeah. Also, I just want to show you guys there's the documentation that's provided by the Virtual Robotics Toolkit. Inside this documentation, there's like different challenges that you can possibly do if you just want to practice your coding, right? And then there's also different ways to navigate the software. If we didn't explain it that clearly, you can always read the guide. Okay, right. And then this is just World Robotics or Olympia. Okay, I'm actually gonna exit, and then I believe, yes, this will work. So you can see that this is provided Virtual Robotics Toolkit that challenges. There's a lot of pretty useful information here, right? First Lego leave, and then you can see these videos. This is just an example of what software is inside the Virtual Robotics Toolkit that you can navigate, as mentioned briefly before. Okay. Any more questions or no?
Oh, just saying, if I saw the past question about EV3 with Scratch, you can. It's just a different download. So it wouldn't be the normal EV3 you would usually get. It would be EV3 Scratch. So if you really want to, you can. Just need to find it online.
Oh, wow, it is a thing. Yeah, I can briefly show it on screen. Just easy to scratch. You can download it. I would recommend you follow their guide because we're not that familiar because I don't believe this is legal. And is it legal in FLL? I'm not sure, but I don't believe it is because it's not provided by the company Lego. So it might be a little, the legality using it during competition might be a little off, but it's still pretty cool to learn, right? You can try learning the block coding, which is kind of different from what the Mindstorms has. And yeah, okay. Aiden or Tyler, do you guys have anything else to mention? I assume that's no. Let's see. I think that's yeah. Is there going to be any more questions in the chat? I'm just gonna wait a second as I'm gonna navigate through something. And then just virtual robotic. Oh yeah, I remember someone mentioning about the code. Right now, you can use the 14-day free trial if you want to. I believe I'm not that specific on it, but I believe Ken has codes to give out. But that's up to Ken. That's why.
Just one of the questions in the chat. That's based on what is the power of, say, the battery. In VRT, there is no battery, so it's always going to be 100% at all time. So it's going to be the most powerful it can be, and it will last as long as your computer can last.
Yeah, and then so virtual robotics toolkit is pretty resource intensive. Like so, that's just something to know. You might not want to have other programs when you're running the virtual robotics toolkit. I'm just gonna go through. I just want to recap on this because like this is super important. Just remember that this is a simple mode right here, and then once we press, Tyler, want to answer it?
Yeah. So what battery in real EV3? So you can either use the normal AA batteries, so 4 of them would go into the brain, or you could get that rechargeable hub. Those are pretty much right now the only options that I know that are legal. So the rechargeable hub, you could just have multiple of them, or if you have the batteries, those should last pretty long.
Aiden, do you have any mention on it? Because Aiden has been to World Festival for FLL. About how long batteries last.
Oh, yeah. For the batteries, they usually last for around, well, I would say like they would last throughout the whole tournament. But the thing is, if you're using the rotations for movement, then like when the battery starts to get below like half, the robot will like slow down a significant amount. So if you're doing like competitive stuff, then I would recommend you bring like 3 batteries just in case, you know.
And then that is actually pretty similar to FTC. And FTC, we're part of the first tech challenge team we mentioned 2 weeks ago. It's just that like battery levels, it just the max, the better, more you fill it, it's better. But I'm not that into physics, so I can't really explain it well. But yeah, it's gonna be better. But it's you're also draining the battery. You're also like damaging the battery if you like charge it max every time.
That's why we have like 10 batteries at the moment.
Okay, let's see. I guess right now we can just show the toolkits again because And this wasn't covered that well, but we can also just gloss over it. And we can also gloss over the other one. And then I believe for last week, we didn't, last week, the links were not that clear on the video. So then what I'm gonna do right now is I'm just gonna show the links that we had from the 2 weeks ago session, from the previous session, just in case you couldn't get it down. Okay. This is just in case you couldn't download the software from last week. Just remember it's right here, and then I think that might be covering, so you might not be able to see this EV3 link. But you can see right here. So this is just in case you couldn't copy the links down, because last week it was glossed a little quickly. Okay. Any questions or comments or concerns? Code review. I believe this is all we're gonna cover for this week. So, yeah. And then thank you for all of you guys in the chat asking questions, and thank you for learning the software. And then on behalf of our team, I thank you guys for watching us.
And thank you, Code Arena, for having us.
Yes. I think briefly mention this is we could have gotten more code, but yeah, this is just I'm just gonna gloss over the presentation again. This is just one of the software. If you're not familiar that much to physical FLL, then it is. I would recommend you get used to that first. But since it's coronavirus, like there might be a little bit of an issue with that. So this is just remember to get used to this view right here, because you're gonna see it so much, right? You're gonna see this view so much, and then you're gonna have to navigate through it a lot. Okay. And then, let's see. It's a little blurry.